Alright, my module's reassembled. Now, I talked about this ignition coil before, and I had mentioned that I wasn't sure on the readings, especially on the primary. I was concerned about that primary winding. It was a very low reading, and it turns out that on this particular type of coil, the reading is supposed to be less than an ohm, so it's actually quite difficult to ascertain whether or not it's the proper resistance reading or not on the primary of this. On the secondary it's a little simpler, but the primary coil or primary winding on this ignition coil, it does have a very, very low resistance, so it's going to look like a short to most meters. So that being said, I did find out that some people have mentioned that they have been able to get a very small spark off of just pulsing 12 volts onto the coil. So I'm going to try that and see how that works out. Now, in my previous testing, I was using this 12 volt DC regulated power supply that I have. This is good for running like car stereos and things like that, but it's got a maximum amperage of 3 amps at 12 volts, and anything over that will trip the internal overload circuitry, and that's not quite going to cut it when I'm trying to pulse a coil. Especially a coil with such a very low primary winding. You figure in Ohm's law would tell us that, yeah, I mean, let's see, at 12 volts, you know, you're talking some serious amps it's trying to draw, even though it's only for a split second. So what we're going to do is we're going to step it up. We're going to use this 20 amp power supply. This has got a little bit more oomph to it, so we'll see if we can't get any action out of that coil. Well, I can't induce a spark jump, the regular gapped spark plug, with just 12 volts going into this coil, which I'm actually not surprised at that, only because this coil is supposed to be seeing a couple hundred volts going to the primary. But I am, just got my meter lead on there, I am looking at the meter, and as I pulse it, I'm definitely getting a reading here. Now this meter here has a neat feature. It has a min-max feature. So what I can do is actually on the voltage setting, if I hit max, it's now recording, and I pulse it, I can actually now look at what the reading was. And it looks like the max voltage was 2.3 volts. Doesn't look like much came out of it. 2.3. Try it one more time, see what happens. The average, 0.02. Alright. Let's see what we got there. Ah, max overload. So at some point it did pulse, and it was out of the limit of the meter. Alright, one more test. This time I've changed the range on the meter. Instead of letting it auto range, I've overrode it so that it's at the higher voltage range. And now we'll try it again. Alright, 8 volts. Not exactly spectacular. Alright, getting real close to firing this puppy up, hopefully. I've got a little spade lug connector on here, so I could expose a bare wire. That's on my purple wire. The purple wire is your 12 volt. So this is when the key's on. This is a constant 12 volt being fed to the module through there. Your black wire actually has a white stripe on it, so they call it the black-white wire. That wire right there normally would go to your points in the distributor section of the motor, and that's your trigger to trigger when it's going to fire. So for this very moment, I'm not going to bother hooking that up yet. And the blue wire, of course, over here we know goes to the ignition coil, which I'm also not going to hook the coil up because I kind of want to see whether or not this thing does anything without that stuff happening. So in other words, I'm going to hook my ground up to the plate here, and then I'm going to apply 12 volts, and I expect one of three things to happen. First thing that could happen is I could get some smoke out of this thing, which would mean that obviously I did something wrong or something was still further wrong with the unit. Second thing that could happen would be nothing. It just sits there and does absolutely nothing. But what I'm hoping I'm going to hear is I'm hoping I'm going to hear a little bit of a noise coming out of it to indicate that the oscillator circuit is running and that it's producing the voltage that would be coming out of the secondary and fed to that SCR. So let's see what happens. I made one more connection, which is I connected my meter so I can monitor the voltage just in case this thing draws so much current that it shorts out my supply. Here goes nothing. Oh, I'm getting a ticking sound out of there. Something's definitely happening. I'm going to shut it down temporarily and just check and see if I feel anything overheating. Alright, no components were overheating, so now it's time to get real brave, put the ignition coil on, see what happens. So again, I still don't have a pulse wire hooked up. I've got the plug on there, but I don't expect to actually see a spark unless there's just an initial one when I first power it up. And then it should just sit there and pretty much not really do much, hopefully. Ooh. Don't know. Didn't like that sound. Of course, the only thing that, if something's cooking in there, what I would expect to be cooking would be the Darlington power transistor. And that could have just been the sound that oscillator makes, but could have also easily been something much more horrid going on in there. Eee. What to do? Interesting. I only did that the first time I powered it up. Now I went back to that ticking. Okay. Shut it down. Okay, I got a sick puppy because it just made that noise again, and then it stops and goes back to this ticking. Ticking is almost as if it's shutting down, like it's trying to come up and start oscillating and shutting down. And what I noticed is that I'm getting actually a little bit of voltage coming out of here, but if I tap this, it goes nuts. So something's wrong. So it's like it's trying, but it's not quite cutting it. So I'm going to shut it down before it tries to blow itself to bits. And shut up. Seems like that sound, tapping on it almost looks like it's a cold solder joint somewhere. So I think what I'm going to do is I'm going to pull that PC board off and see if I can't find any bad solder joints. Well, there just aren't that many connections on here, so I'm going to reflow every connection. I already redid a few of them, just hit and miss kind of thing when I was putting the new transistors in, but now I'm going to reflow them all. Okay, I reflowed every connection in there. Basically heated it up and resoldered every connection in there, flowing good solder in. And sometimes when you go to resolder a joint. If it's a cold solder joint, sometimes as soon as you hit it with the iron, you know it was bad just by the way it acts, sputtering and bubbling. And I'll tell you, a lot of these were acting that way. But anyways, I've redone every single joint that I could see in there, and then I looked at it all under magnification and checked for any inadvertent solder bridges or tiny balls of solder that might have fired off and gotten in the way, and made sure that that was all clean. And now I'm ready to fire it up again. I gotta reconnect my ground. All right, let's see what we got. Same damn thing. Tick, 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 tick. Oh. What's different now, though, is we now no longer have an intermittent sizzle coming out of it. So something's changed. Well, let's hook the coil back up. That's just the metal case vibrating. Well, guess I'll put a trigger wire on and see what happens. Alright, first test with the trigger wire attached. I'm going to just touch it momentarily with the ground lead and see if I hear any change in the oscillations. Well, I am hearing an arc somewhere. I'm getting that corona discharge odor. For those of you who aren't familiar with that phenomenon, it's something you might, after a spring thunder shower, you smell it in the air. It's a sweet smell in the air. And what that is that's ionized air from lightning. But you also get it whenever you have the presence of a high voltage arc. So what I'm thinking is, I've got my coil sitting right here on top of the power supply case, and I'm willing to bet I've got an arc coming out of that sucker when I'm pulsing it. Bet you it's arcing to the case. I don't have a ground hooked up on my spark plug, so I'm not going to be able to get anything there anyways, but I'm definitely getting something here. Oh yeah, right there. You can see there's some dust right on top of the case. You can actually see it sticking to the insulation on that coil. Let's see if we can't see anything. Might be actually in the plug wire itself. Might have an open. I couldn't get a reading on the secondary winding, which bothered me. I wonder if I've got a bad wire in the secondary, and what I might be hearing is I might be hearing the internal. It might be jumping it internally. Although why would it want to be jumping it to go there? I've got no return ground path. I don't know. Let me reposition that coil. Okay, rigged up some stiff copper wire to go to my negative terminal on my power supply to ground my spark plug, and keep it up in the air. So now I've got my high tension lead. Got that on the wooden workbench. So now that should be fairly isolated. And now I've got my pulse set up here, so let's try it again. And we got a nice spark. Nice hot spark too. I'll turn the light off for you. Closest I can come to simulating the engine running is what I'm doing is I'm lightly dragging this across the conductor, and that's simulating a whole bunch of firings in a second. I've got a working module, everybody. Okay, I popped this cover back on. Actually just slides on over this and actually worked out. Fits pretty tight, and I popped in what was left of the plastic studs. Essentially what they did when they assembled this was they're just plastic pins that stuck up on the bottom side here, and then they melted them down. I ground those off in order to get the case off. So what's left of the pin is stuck in there, so it's going to keep it located, but it's not going to really be a tight fit. So what I'm going to want to do is come up with something. I'm probably going to put some silicone or some type of a sealant around this whole edge right here, and that should keep any moisture from getting in there.